So good morning, everyone. For the next session, we have with us Dr. Sandeep Shirkhedkar sir, and he will be delivering his session on advanced surveying and mapping. Now, allow me to introduce you, Dr. Sandeep Shirkhedkar sir. Sir has done his PhD in civil engineering, postgraduate diploma in disaster management, postgraduate diploma in work marketing management. Sir is presently the director of Imagis Engineering Solution Private Limited, as a and the vice president at Association of Consulting Civil Engineers. Sir has many life memberships, namely life membership in Indian Road Congress, life member in Indian Concrete Institute, life member in Indian Water Work Association, life member at Indian Society of Remote Sensing. Sir, I've completed many projects, namely road planning, mapping, and designing 3,000 kilometers, road safety audits, infrastructure design for various cities and industries, designs of river linking projects, drainage studies and design, flood zonation, road traffic surveying and data analysis, road inventory management, metro rail alignment and other consultancy, stormwater drainage design for rural and urban areas, DP road demarcation, layout mapping and planning, LIDR surveying and road condition assessment, drone mapping for infrastructure planning, water conservation, seismic studies, and so on. Now I request sir to start with this session.
Yeah, check whether I'm audible.
Yes, sir, you are audible.
Yeah, good morning. Uh, this is Sandeep from Imagis Engineering Solutions Private Limited. Uh, 30 years we are into surveying and mapping, and this is really a very nice opportunity for me to share my experience and knowledge and exposure which I have uh, about this surveying and mapping industry with you all. I congratulate this Anjuman College of Engineering and Technology for conducting this sort of STTP. And it gives a nice opportunity for the participants to know what exactly is happening in this world. And I'm here with you to share the things about modern surveying and mapping technologies. Like every discipline, this discipline is also advancing very fast. And we as an engineer, we as a technocrat, we as a student, we as a faculty member need to upgrade ourselves and to should know what are the technologies, and this sort of platform certainly helps us to know what is happening. So now our syllabus, our curriculum has got a lot of things about traditional surveying techniques like chain, compass, blendable, theodolite, dumpy level, automatic level. Few of the syllabus may have total, even a total station or a GIS things. But yes, the major part of advanced mapping techniques is very well missing from our syllabus, and that is what I'll try to cover today. I'll be speaking more about drone technologies, mobile mapping, lidar technology, satellite technology, underwater, underground survey technology. So, to my opinion, these things will certainly be new things for you, and it will help you to convey the message to the society, and it will be a great help to our engineering fraternity. So yes, we conduct a survey and surveying for mapping of various objects. It may be map of country, map of continent, map of state, region, city, colony, map of a plot, field, river, road, whatever, or utility. Any object which is present on the surface of the earth can be mapped by using various surveying techniques. And the basic principles of these techniques we all are very much aware. We are during our curriculum, like orientation of a instrument, or what is not direction, what is scale of a map. So basic things we all are aware, and what are the various distance measurement techniques available. So what are the advanced techniques that we'll try to understand today. So another application of surveying is also for a setting out of object. It may be a setting out of a building or a plan or a road or a utility or a zone or a canal, fields, dam, boundary, whatever. So, like as shown in this figure, setting out of the column putting positioning is being marked by using the survey techniques. Very simple techniques is used here. Only chain or tape is being used to map this. Yes. So these are the few traditional techniques which we are aware of: dumpy level, automatic level, prismatic compass, plane table, vernier theodolite. So this we also have ourselves conducted various assignments practical during our curriculum, and we are very much used to these techniques. This is what I presume, and this is what I understand. But these techniques has got certain limitations, like as compared to the today's advanced technologies. The time required for preparing a map is much more in these technologies than what we used to consume today. Then the accuracy is another thing on which these recent technologies are have worked very hard and came up with a very accurate solutions for us. Like in a prismatic compass, we have accuracy of half a degree, that is 30 minutes. Like theodolite, 20 seconds. While measuring at elevation, this leveling staff has got this count of 5 millimeters. But these days, very super accurate instruments are available. You can even map a fraction of millimeters by using the advanced technologies. Like another limitation of this traditional technology is you don't know where exactly on the surface of the earth the object is. No? Now, with these new technologies, by you taking a help of GPS, that is global positioning system, we can identify our position on the surface of the earth, and it becomes very easy for me to connect the various database. Like if somebody asks me to conduct a survey for Anjuman complex and someone is doing it for the VNIT premises, and if I need to combine these two surveys, then yes, we need to know global positioning of the objects present at both the locations. And with the help of traditional techniques, this may not be possible, yes, but we are. Human resources. In the traditional surveying techniques, we need a lot of resources to conduct the survey, whereas the requirement of resources is very limited while we use these advanced technologies. Then comes uh, weather. You can work in all weather condition. Like plain table, you may be knowing under moist condition it's not possible to work, but yes, in the new technologies, very much we can conduct the mapping operation even during a rainy season or a monsoon. And next is drafting. So you have to collect data sets and then go to the office, and then on a drawing sheet or a graph sheet or maybe on AutoCAD you have to draft those things. The data I'm talking about, data which has been collected by using the traditional techniques. The drafting is also a challenge, but nowadays the most of the data is collected in a digital format, and it is very easy to prepare a drawing, and most of the drawing work is being done by the software itself. So before moving to the technologies, we need to have our concepts clear about coordinate geometry. Coordinate geometry we have been learning since ages, since the 6, 7 standard. We are using we are taking help of coordinate geometry for preparing maps or the graphs. So, like a graph sheet, this Earth is also a graph is like a graph paper. It has got x and y coordinate. As you may be knowing, latitude and longitude. Horizontal line we called as latitude, whereas vertical line we called as longitude. So every point on the surface of the Earth has got unique latitude and longitude. You must be agreeing with me. Every point on the surface of the earth has got unique latitude and longitude. And it makes my work very, very easy and very simple, because every point, maybe in India, maybe in Africa, maybe in America, has got a unique latitude and longitude. Okay. So, and the elevation, generally we refer it to the mean sea level. As you may be know, for India, we observe elevation with respect to mean sea level at Karachi. So X, Y, and Z coordinate, distinct northing and elevation in the language of survey. Distinct X direction, northing, Y direction, and elevation Z direction. So X, Y, Z. So once we know X, Y, Z of any point under consideration, it becomes very easy for me to generate the map of that particular object. It may be anything. It may be a road or a hill or a tree or a house or a room or a table which I'm sitting on, whatever. Just to cite an example, let us consider one room. We, being a civil engineers, we are very much aware that the room is generally rectangular in shape. I'm considering a room with a dimension of 5 meter by 4 meter and height as a 3 meter with one door, one table, and one window. Now, if somebody asks me to generate a map of this room, 3D map here I'm talking about. So I need a coordinates of only 8 points. If I opt to get the coordinates of these 8 points, it is very easy for me to not only to generate a map, a plan, or I can also generate the elevation and I can also generate the 3D view. These 8 points I'm talking about, 8 point representing the entire room. And if we discuss about coordinate system, different point, if we assign the coordinate as 0, 0, 0, x, y, and z coordinate, then the coordinates of all these 8 points are mentioned over here. So with reference to one point, we have considered this point as a reference point, and we could identify the coordinates of this point. Imagine by virtue of some technology, if we get the coordinates of these 8 points, my survey becomes very easy. The data collection becomes very easy and drafting becomes very easy. देखिए हमारे पास एक्स वाई जेड कोऑर्डिनेट्स है ये 8 पॉइंट के, उससे आधार पर हम इसका प्लान एलिवेशन इसका 3D व्यू तो बना सकते हैं. सो एक्स वाई जेड कोऑर्डिनेट कैसे लाना कैसे निकालना वो नई टेक्नोलॉजी से हम सीखेंगे. और ये भी और भी कुछ मैंने पॉइंट्स इसमें जोड़ दिए मेरे इस फिगर में जो कि रिप्रेजेंट कर रहे हैं मेरे विंडो को, डोर को, टेबल को. So this is set of points for which I need a information. I need a x, y, z coordinates. If we see, observe all these points together, ये सारे points को मैं देख रहा हूँ, ये देखिए. So you will find n number of points over there. And this point we call this as a point cloud. ये सारे points को हम point cloud बोलते हैं क्योंकि ये points को x, y, z coordinates है. So this is a point cloud. So by most of the instruments which we will be discussing today works on a point cloud. यानी एक जगह खड़ा है सारा चीज स्कैन कर लेता है आपको उसका एक जो भी आपने रेफरेंस दिया है उसके रेफरेंस में बहुत सारे पॉइंट क्लाउड हमारे पास आ जाते हैं. फिर हम डेटा को एनालाइज कर सकते हैं. हम with the time we will discuss, we'll come to what exactly is point cloud and how the point cloud is utilized for the benefit of our fraternity. सो एक हम बेसिक इंस्ट्रूमेंट से शुरुआत करते हैं. इसको हम एडवांस मॉडर्न मैजिकल कुछ भी बोल सकते हैं क्योंकि हालांकि अभी 25 साल हो गए इस इंस्ट्रूमेंट को आके, लेकिन आज भी इसका डोमिनेशन कम नहीं हुआ है. जब आया था 25 साल पहले ना, इतना मिराकुलस लगा था. मैं तो इसको मैजिकल इंस्ट्रूमेंट बोलता था. टोटल स्टेशन क्या है कि इसके पहले की सारी टेक्नोलॉजीज जो है उस पर हमें डिस्टेंस इन जनरल मैन्युअली मेजर करने पड़ते थे. मैन्युअली मेजरिंग के डिस्टेंस. अब मैन्युअल डिस्टेंस मेजर में आपको तो जानते ही है कि लाइन ऑफ साइट सीधी होना चाहिए, टेप हमारा सैग नहीं होना चाहिए, टेम्परेचर बैलेंस होना चाहिए, टेम्परेचर करेक्शन लेना है, एक्सेसिव कूल हमको लगाना नहीं है ना, नीचे के बुशेस वगैरह क्लियर करना है, टेप हमेशा एग्जैक्टली हॉरिजॉन्टल चाहिए. ये सारे चीज से हमारे काम में जो एरर आता है ना, इसके तरफ हमेशा हम ध्यान दे ही सकते. विंड में जो है टेप झूलता रहता है. सो विद दिस इंट्रोडक्शन ऑफ दिस इंस्ट्रूमेंट इट वाज फिटेड विद ईडीएम, इलेक्ट्रो डिस्टेंस मेजरिंग यूनिट इसमें रहता है, और बाय वर्च्यू ऑफ व्हिच वी गेट द डिस्टेंस बिटवीन 2 पॉइंट्स. नॉट ओनली हॉरिजॉन्टल डिस्टेंस बट वर्टिकल डिस्टेंस, sloping distance, everything it used to give this EDM. And now, if this EDM is attached to this total station and digitally it helps me to find out the coordinates, directly coordinates. Like we have to consider prism as ऑब्जेक्ट. यहाँ एक प्रिज्म होता है, इंफ्रारेड रे हमारे इस इंस्ट्रूमेंट से जाता है, प्रिज्म को हिट करता है, और वापस आके हमें उस प्रिज्म के कोऑर्डिनेट्स मिलते हैं. Nowadays, in many of the cases, even we don't need this prism. The telescope, जैसा हम इस पे करते हैं ना, बंदूक का निशाना लगाता है, क्रॉस हेयर रहता है उसमें. सो क्रॉस हेयर जिस ऑब्जेक्ट को टच करता है ना, उस पॉइंट्स के कोऑर्डिनेट से हमारे पास आ जाते हैं. सो इमेजिन कीजिए, आप जिस बिल्डिंग में बैठे हो उसकी हाइट हमें गिनना है. अगर डंपी लेवल से गिनना है तो मुश्किल नहीं है, मुश्किल है बहुत. हाइट गिनने के लिए तो हम डंपी लेवल ही यूज करते हैं, ऑटोमेटिक लेवल ही यूज करते हैं. ये टेलीस्कोप से सीधा टेलीस्कोप टिल्ट कर लो, ऊपर का पॉइंट ऑब्जर्व कर लो, हमारे पैरापेट वॉल का हमें एलिवेशन मिल जाएगा पॉइंट्स का. सो इतना आसान है. एक्स वाई जेड कोऑर्डिनेट्स पॉइंट के वो हमारे मोबाइल, हमारे इस मशीन के स्क्रीन पे डिस्प्ले हो जाते हैं. सो इंफ्रारेड रे, ये प्रिंसिपल पे ये इंस्ट्रूमेंट हमारा काम करता है. वेरी प्रिसाइज, वेरी एक्यूरेट. 1 mm एक्यूरेसी से ये डायमेंशन ले सकता है, और एंगुलर एक्यूरेसी 1 सेकंड. इमेजिन कीजिए, प्रिज्मेटिक कंपास जो हम बात कर रहे थे 30 मिनट्स का, थेडोलाइट, वर्नियर थेडोलाइट हम बात कर रहे थे 20 सेकेंड्स का, और अभी ये 1 सेकंड का हमारा टोटल स्टेशन आ गया है अभी. सो माई थिंग्स बिकम वेरी इजी, माई मैपिंग बिकम वेरी इजी. सो ये मैजिकल इंस्ट्रूमेंट है. एक बार जैसा कि यहाँ राइट साइड में इमेज में आपको दिख रहा है, जस्ट यू हैव टू फिक्स द इंस्ट्रूमेंट ऑन अ ट्राइपॉड एट वन लोकेशन एंड स्टार्ट ऑब्जर्विंग द पॉइंट्स. यू हैव टू कैरी द प्रिज्म, और यू हैव टू डायरेक्टली ऑब्जर्व द पॉइंट्स. रोड एज हो, इलेक्ट्रिक ट्रांसमिशन लाइन का टावर हो, ट्री हो, पहाड़ी हो, हाउस हो, घर के कॉर्नर हो, ये सारे एक एक पॉइंट, रोड का सेंटर हो, ये एक एक पॉइंट का हम डेटा कलेक्ट करते हैं, और ये डेटा इंस्ट्रूमेंट अपने मेमोरी में स्टोर करता है, और ये मेमोरी में स्टोर किया हुआ डेटा हम डाउनलोड कर सकते हैं. आई होप द अंजुमन इंजीनियरिंग कॉलेज हैज गॉट अ टोटल स्टेशन विद देम एंड दे आर यूजिंग इट इफेक्टिवली. सो ये टोटल स्टेशन है, मैजिकल इंस्ट्रूमेंट है. ये हमें डिस्टेंस मेजरमेंट की जरूरत नहीं है, हमें कोऑर्डिनेट्स हमें हमारे पास आ जाते हैं. यू कैन राइट अ डिस्क्रिप्शन अगेंस्ट द सेव्ड कोऑर्डिनेट, लाइक रोड एज है, या फ्रंट साइड, लेफ्ट टर्न कॉर्नर, साइड कॉर्नर ऑफ अ हाउस, वॉट एवर डिस्क्रिप्शन यू विश टू राइट. बिकॉज ये जब डाउनलोड करेंगे तो पॉइंट पॉइंट आएंगे, तो कौन सा पॉइंट कौन सा है उसको आइडेंटिफाई करने के लिए there is a facility called as description. We can write a description in a specified column, and we can uh, get the description along with the coordinates of that point. Okay. So yes, the magical instrument I told. देन एक सैंपल ड्राइंग है, कंटूरिंग वगैरह जनरेट करके इस प्रकार का ड्राइंग हम जनरेट कर सकते हैं. जो जो लाइंस जा रही है वो कंटूर लाइंस है. वी ऑल नो व्हाट इज कंटूर. दोज हु डोंट, contour is a line representing equal elevation. If we move along this line, you'll find the same elevation, right? So this is about the total station. Uh, I want to hear something from you just to check whether you are listening, or whether you got yourself busy with some other activities. Uh, किसी को टोटल स्टेशन के बारे में कुछ पूछना है या बताना है तो ही और शी कैन आस्क मी राइट नाउ. जस्ट मैं किसी की आवाज सुनना चाहता हूँ, क्योंकि मैं यहाँ बोर हो रहा हूँ अकेला बात करके, क्योंकि दिख भी नहीं रहा है मुझे कि कौन मुझे देख रहा है. चलिए, यस प्लीज. यस. मैं किसी से कुछ सुनना चाहता हूँ. एम आई ऑडिबल? उतना तो आंसर कीजिए. Hello. Yes. Azad sir. Hello, Azad sir. Ashwini madam. Hello.
Hello.
Azad sir.
Yes, sir.
पार्टिसिपेंट्स है या नहीं पता ही नहीं चल रहा है, कोई रिस्पॉन्ड नहीं कर रहा है। पिछले मैं 4 मिनट से पूछ रहा हूँ किसी को कुछ बोलना है या मैं कोई आवाज सुनना चाहता हूँ। यहाँ मुझे
Uh,
किसी की भी आवाज नहीं आई, ना ऑर्गेनाइजर की आई, ना कोई पार्टिसिपेंट्स की आई। सो हाउ आई विल कम टू नो दैट वेदर आई एम ऑडिबल,
sir,
वेदर थिंग्स आर
actually,
वर्किंग
they are
फाइन।
viewing your presentation on YouTube. So, if
हाँ
they want to ask any question, they can post their question in the comment box.
हाँ।
So, right now, there is no question in the comment box.
ओके ओके। सो it is not a two-way
Yes, sir.
two-way things.
After
Okay.
the session, it will be uploaded on the YouTube, and they
Okay.
can view after that also.
Okay. Okay. ठीक। So yes, after total station, I'll talk something about this satellite technology. So first of all, first thing is satellite mapping. It is an image. It is nothing but a photograph taken from a top. Photograph taken by a satellite. This is one of the photograph. I suppose yes, it is of Mumbai region. So yes, this photograph comes with certain scale. It is not the photograph like what we click through our mobile or a camera. It is a photograph clicked by some specialized camera, mapping grade camera, which gives me accuracy wherein we can also measure distances here. We can find out the areas. Many of you might have used Google Earth. Google Earth is also a satellite imagery. There are various satellites which collect the data and provide us the imagery, satellite imagery. So this is one of the precise satellite imagery. Google Earth also has got a precise one, say up to accuracy of one meter. Means we can identify object of 1 meter by 1 meter. Each pixel, those who are aware about photography may be knowing what is pixel. Each pixel has got a resolution of 1 meter by 1 meter. So, and nowadays we have the satellite imageries with the resolution of even 0.3 meter. So yes, we can even identify object of zero point 0.3 by zero point 0.3 meter. So even this the chair on which I'm sitting can be identified through satellite, and my mappings become very easy. छोटे छोटे ऑब्जेक्ट्स भी 0.3 मीटर वाले ऑब्जेक्ट्स भी आजकल हम सैटेलाइट इमेज से आइडेंटिफाई कर सकते हैं। सैटेलाइट इमेज ऑल्सो हेल्प अस टू नो द एलिवेशन। सैटेलाइट इमेज से हमें एलिवेशन भी मिलते हैं। But now, till now, the technology is not that accurate enough to identify the very precise elevation. But yes, in general, what is the slope of the area? Where are the undulations? And not a smaller one, but yes, some regional undulations can be identified by taking help of satellite imageries. So this is one of the 3D map of some areas wherein this data is captured through satellite, and my elevation modeling also become very easy. Each color representing a different set of elevation. Color scale we have given, and green color indicates lower elevation than the red color. So this is how, if I'm supposed to map or identify or generate the data, some regional level data, the satellite imageries can very well help me to get even the the contours at a certain level of accuracy. And this is image of institution of engineers metro station, and even for wherever you are staying, wherever you are working, you can find those locations on the Google Earth satellite imagery. Google Earth is a open source application. You can download it and you can start using it. You can also measure the distances. So one of the study which we have conducted by using this satellite imagery is change detection study. I was required to identify what is changed from 2009 to 2015 in a slum area there adjacent to Bombay Airport, Mumbai. What I could get is a 2% increase in area of road, 35% increase in the ground storage building. So many of the ground storage building were converted to G plus one structure, and 48% increase in a double storage building, and some open spaces were decreased. And this sort of information we can get very easily because some historical satellite images of any area are also available. You can compare the pre and post data. Like me as a hydrologist, I studied this flow regime of one of the river in the outskirts of Nagpur, and in 2000, the central black line indicates the stream, the water carrying passage. So yes, with the time, encroachment has happened, and now stream started, squeezing. People started squeezing the stream, and in 2017, this is the case. So a lot of encroachment. This is true color satellite imagery. ये जो सफेद सफेद दिख रही है ये मकान है, और जो बीच में ब्लैक कलर दिख रहा है वो नाला है. Now, if we compare the flow regime, 2017 में एक 872 क्यूबिक मीटर पर सेकंड का डिस्चार्ज जाने के लिए जो हाई फ्लड लेवल रहती थी वो आज 2017 में ऊपर हो गई है. क्यों? क्योंकि हमने हाई फ्लड लेवल जोन का जो है एरिया इंक्रोच कर दिया है. So these all are the reasons of urban inundation, urban flooding जो बहुत कॉमन है आजकल. एक तो रेनफॉल इंटेंसिटी बढ़ रही है और ऊपर से हमने ये इंक्रोच किया है. सो इसका मतलब वर्स थिंग्स आर हैपनिंग. और बहुत सारे सिटीज, वो चेन्नई लो 2015 में, मुंबई लो 2005 में, लास्ट ईयर 2022 में आप बैंगलोर लो, ये सारे उदाहरण इस चीज के हैं कि हमने हमारे वाटर पैसेजेस जो है उसको इंक्रोच कर दिया है, उसको स्क्वीज कर दिया है. Right? So yes, this sort of study is possible by using a satellite imagery. I'm trying to share all these things because it will not only give you certain insights about what is happening, it will also give certain insights about how you should proceed further for whatever research you are into, whatever project you are into, or this may also give you certain ideas what should be your probable projects assignment or the career goals, etc. I'm sure this information will help you a long way. Another instrument which we use extensively is GPS, Global Positioning System. It is satellite-based system. Round the clock satellites are available. Round the clock we can find out the XYZ coordinates which we normally use. We use this GPS in general for the navigation purpose, wherein for getting a direction or reaching some location, like if here I am right now on a Varda road, and if I'm required to come to Anjuman College, yes, I'll put the destination as Anjuman College, and this Google Earth, this mobile map or a GPS map Google Map will guide me to your place. So this is how we use the GPS. The use of GPS is very common, and this GPS, which in a mobile, it comes with certain level of inaccuracies, like up to plus minus 4, 5, 6, 7, 8 meters you can reach by using this instrument. So for a navigation purpose, it is good enough, but not for a surveying, precise surveying and mapping purpose. If somebody asks me to find a distance from Nagpur to Delhi, yes, I can observe Nagpur by GPS and go to Delhi, observe Delhi by GPS. So 10 meters and here and there will not affect much in a this much of passage, say thousand more than 1,000 kilometers. But yes, for a small surface, for a plot surface, this 4 5 even 3 4 5 meters may not be sufficient for our requirements. So for that GPS in a differential mode, what we call, there is an app you can download. So open source app called as Handy GPS. This gives you X, Y, and Z coordinates of any point under consideration. But yes, as I told you, with a certain level of inaccuracies. But for reconnaissance survey or for general survey, it can be used. So GPS in a differential mode, what generally we use for the precise survey, wherein 2 points are observed simultaneously, one known point and another unknown point. On the known point, we fix a, tripod and one base observing the data. So based on the rover combination we use, accuracy can even be up to 5 millimeters. To my opinion, it is super accurate system. Even in a total station, if you need to observe imagine one point is on one side of my building, another is on another side of the building. And for total station, I had to observe one point, move around, take a total station through a way through which I can reach to a rear side and then reach to a point, observe the reading. But this satellite, this GPS being connected with the satellite, I'll go and on the front side observe a reading, I'll go on the rear side observe a reading, and that's all. I'll get the coordinates of point under consideration. So this is a very fast method. Round the clock satellites are available. Even during the rains, you can uh, conduct your surveying activity. So yes, very extensively you being used, and nowadays at most of the projects it is a very good replacement for the total station because the work speed has increased with the invention of this GPS in a real-time kinematic mode, RTK mode, what we call. You can write down your questions at the end of the today's discussion. I'll try to answer those questions. Then nowadays, very common people gets fascinated with this. It is drone technology. Drone, yeah, drone generally people use it for taking for a video shooting or mapping certain things. But this for getting a information, and but this our application is related to the dimensions, elevations, etc. And for this we have to use the mapping grade drones. This is mapping grade drone which I shown over here. It does not carry the videography cannot be done by using this. You can get a image to the scale image by using this drone. So resolution, what I was talking about is for a Google Earth satellite imagery, we get up to 1 meter resolution. Then for certain satellites, zero point 0.3 meter is also available. But with drone, we can go up to 5 centimeter. This means you can identify object of even a 5 centimeter by 5 centimeter by doing this drone survey. Uh, One of the example here, uh, how this drone survey is used or how the survey is conducted. So before going to site, we have to do flight planning. So this is the zone. My flight will move or my drone will move exactly along the programmed path, and now it will reach there. Yes, going. My drone is reaching to a starting point. Yes, it has reached and now started collecting the data uh, uh, by moving along the specified path. So now data is collected and my drone will fly back. So in few minutes, my very big data set is collected. Now, this is not a photograph, let me tell you. This is a point cloud. Every pixel, every point has got X, Y, and Z coordinate. यहाँ पे हर पॉइंट को, ये पिक्चर नहीं है, फोटो नहीं है, यहाँ हर पॉइंट को एक्स वाई जेड कोऑर्डिनेट है। आप इसको जूम करेंगे आपको पता चल जाएगा कि हर पॉइंट को एक्स वाई और जेड कोऑर्डिनेट है, और एक रेफरेंस के आधार पर, और जो कि ड्रोन ने ये चीज कैप्चर किया है। देखिए मैं जूम कर रहा हूँ यहाँ पे, और जूम करते करते मुझे ये सारे पिक्सल दिख रहे हैं, ये सारे पॉइंट दिख रहे हैं, और हर पॉइंट को एक्स वाई जेड कोऑर्डिनेट है। इतना सारा डेटा हमारे इस ड्रोन ने कलेक्ट कर लिया है एक्स वाई जेड पॉइंट्स का। सो पॉइंट क्लाउड इसी को बोला जाता है। एक बार ये हमारे पास डेटा आ गया तो डेटा से हम मैप जनरेट कर सकते हैं। तीन जो शेड्स वगैरह थे उसके हम एरियाज निकाल सकते हैं। हमारे इस टास्क में मेरा टारगेट था वॉल्यूम निकालने का। ये यहाँ जो कोयला रखा है ना, ये कोयला का वॉल्यूम कितना है। सो जस्ट क्योंकि हर पॉइंट को एक्स वाई जेड कोऑर्डिनेट है, और वो वॉल्यूम एस्टिमेशन के सॉफ्टवेयर है, हम सिविल 3D सॉफ्टवेयर से भी यूज कर सकते हैं। और 7224 क्यूबिक मीटर का वॉल्यूम वहां पे आ गया था मेरा। सो बहुत कम समय में बहुत प्रिसाइज डाटा हमें मिलता है। अब देखिए यहाँ पे कि थोड़ा पहले ये इतने सारे अंडुलेशंस ये कैप्चर कोई भी मेथड से हो नहीं सकते। It is only because the drone is there, we are able to capture all these even small undulations, which will help me to get a very precise quantity over this area. Okay, so yes, drone, satellite technology, drone, बहुत काम की चीज है। Then I'll share one more assignment जहाँ की हमने ये ड्रोन और सैटेलाइट इमेजरी इस दोनों का कॉम्बिनेशन यूज किया था। This is for to identify the greenery of Nagpur city. ग्रीन सिटी है तो जाने तो सही कि कितना ग्रीन सिटी है ये। सो नागपुर इज डिवाइडेड इनटू 38 प्रभाग, जो कि ये ड्राइंग इंडिकेट कर रहा है। और फॉर एवरी ट्री वी आर ट्राइंग टू मैप द कैनोपी ऑफ अ ट्री। ट्री की कैनोपी, कैनोपी यानी ट्री का स्प्रेड कितना है ना, वो हमने मैप किया। ग्रीनरी कैलकुलेशन के दो टाइप है, एक तो काउंट द नंबर ऑफ ट्रीज, और यू कैन इवन काउंट दिस एज आई टोल्ड यू the canopy, you can measure a canopy. So by using a satellite imagery ये trees की canopies identify किया। और कुछ critical areas में we have used drone, like यहाँ दिख रहा है जैसा अजनी का एरिया था हमारा, बहुत सारे पेड़ है वहाँ पे। सो इसलिए उस एरिया को we have captured by using drone। ये हमारा अजनी का एरिया जिसपे ड्रोन से डेटा कैप्चर किया जा रहा है। यस, ये दिस इज आवर आजनी ब्रिज, जो ट्रैफिक जा रहा है, और रेलवे के रेक्स भी हमें दिख रहे हैं, और ये यहाँ ग्रीनरी है। सो यस, फिर सारा डेटा कंपाइल करके, ट्रेसिंग करके, कैनोपी जो है उसके आइडेंटिफाई करके, एट द एंड ऑफ द डे इस प्रकार का मैप हमें नागपुर का जनरेट करने मिला। सो देर आर फ्यू प्रभाग जहाँ बहुत ग्रीनरी है, और एट द सेम टाइम देर आर फ्यू प्रभाग जहाँ पूरा ड्राइनेस है। So at the end of the exercise, this was outcome. There are certain प्रभाग like 14 number जहाँ 40% की ग्रीनरी है, और certain प्रभाग like 4 number जहाँ सिर्फ 2% की ग्रीनरी है। 40 कहाँ और 2 कहाँ, इतनी डिस्पैरिटी हमारे इस नागपुर शहर में है। And for that matter, most of the cities reflects the same signature. Mysore being a greenish city of this country, I tried to analyze even the Mysore area. I could get the similar results. So yes, for the equity development, this is not at all acceptable. So we need to plant more trees in the red zone areas than the green zone, because green zone is all. Let us talk about eco sounder underwater survey. A very simple instrument is being used. This study is for sedimentation analysis for one of the reservoir in Andhra Pradesh. My job is to find the quantum of sediment accumulated. आप जानते हैं पानी के साथ साथ जो है सेडिमेंट भी वही कराता है और क्वांटिफाइंग एंड सेडिमेंट जनरली डिसाइड द लाइफ रिमेनिंग लाइफ ऑफ अ डैम. सो ये इको साउंडर है. इको साउंडर पानी से जा रहा है और जीपीएस सिस्टम अटैच्ड है. एग्जैक्टली नेविगेट उसी लाइन से हो रहा है जिस लाइन पे हमें चाहिए और उस लाइन पे हमें डेप्थ मिल रही है रिवर बेड की, हमारे रिजर्वायर बेड की. फिर ये डेप्थ मिलने के बाद सारा डाटा एनालाइज करके वी कैन जनरेट द कंटूर प्लान फॉर अ रिजर्वायर बेड. ये रिजर्वायर बेड का कंटूर्स यहाँ पे हमारा बन गया है. सो कंपेयरिंग विद द प्री प्रोजेक्ट सिनेरियो और अर्लियर डेटाबेस वी कैन फाइंड आउट व्हाट चेंजेस हैपन. एंड ये 3D व्यू है उसका, व्हाट चेंजेस हैपन. एंड यस, वी कुड गेट दैट 5% सिल्टेशन वाज देयर. 5% का सेडिमेंटेशन हमारे इस पर्टिकुलर प्रोजेक्ट में हो गया था. सो ये है हमारा इको साउंडर जो कि हमें रिवर बेड की इंफॉर्मेशन देता है. वैद्यमेट्रिक सर्वे आपने सुना होगा ना, ये वैद्यमेट्रिक सर्वे है पानी के नीचे का. फिर नाउअडेज ड्रोन और इको साउंडर ये भी एक साथ यूज होते हैं. हमने ये अभी तक यूज नहीं किया है लेकिन ये इट कैन बी यूज्ड. ये इको साउंडर है जो कि ड्रोन का अटैच्ड है और ये पानी में जा रहा है, मूविंग along the predefined path and gathering the information, depth information. इको साउंडर ड्रोन से जहाँ इनएक्सेसिबल है, जहाँ बोट का पॉसिबल नहीं है, तो वहाँ यू कैन यूज दिस सॉर्ट ऑफ फैसिलिटीज. ये ड्रोन की बैटरी चेंज होके वापस फ्लाई हो रहा है, इको साउंडर वापस जाके डिजायर पाथ पे घूम के वो डेटा कलेक्ट करेगा. यस, एंड दिस इज व्हाट वी गेट एट द एंड ऑफ द डे. ये हमारा रिजर्वायर बेस के प्रोफाइल एंड वी कैन compare it with the earlier data sets to get the sedimentation. You can find out big fish. You can study the aquatic life or whatever scenario is there, pollution below water, that thing can be analyzed. Now after under water, let us try to find out where the technologies are as far as underground is concerned. So one of the technology available is pipe and cable locator. Generally, conductive objects are identified, maybe metallic object, electric objects are identified by using this. Electromagnetic waves are passed, and you can detect the location and depth characteristics. So if I'm required to map underground utility, यानी जमीन के नीचे अगर कोई यूटिलिटी है उसको बिना खोदे हमें ढूंढना है, तो yes, we can use this pipe and cable locator. इलेक्ट्रोमैग्नेटिक वेव्स, पाइप के अगर ऊपर है हम तो सबसे हाई सिग्नल रहेंगे और दूर है तो लो सिग्नल जाएंगे. ये देखिए एक हमिंग साउंड आ रहा है. दिस इज वन ऑफ माई प्रोजेक्ट जो कि ओएनजीसी के लिए आंध्र प्रदेश में किया गया था. यू विल हियर अ हमिंग साउंड ओवर हियर. Humming sound will be there only when I'm exactly on the metallic object. Now, yes, we are trying to identify if there is any other utility, any other pipeline. This project I'm talking about, the cross-country pipeline. ONGC has laid their gas pipeline long back, and our job was to identify what exactly is the path because there are very less ground marker available. And another two surveyors, they are by using a GPS, they are observing the coordinates of this pipeline. So humming sound means exactly moving on a pipeline. So this is how this very perfect instrument without a non-destructive instrument, without or without creating additional trenches, we can find out the location, depth, characteristics of a pipeline, metallic pipeline. But challenge was when there is a crisscrossing. If my one pipeline starts from GCS and crosses other pipeline and move in other direction, there is every possibility that this may mislead my mapping accuracy. So in that case, we have one solution. You have to attach a generator to this particular one pipeline, and you'll get a higher signal only along this pipeline. So the identification very easy. Like that, my next assignment was to find out the location of a pipe for the Mahanagar Gas Limited there in Mumbai city. And yes, my this was my task. Among all these complicated pipelines, I was required to identify only Mahanagar Gas Limited MGL pipeline. So yes, very simple. As I told earlier, that the generator was attached to a system, and now my this pipe locator instrument will start working, and it has started working. And this point is identified wherein the depth of the pipeline was 1 meter from this surface. Now he is trying to find out the exact path which was followed for laying of this pipeline. And yes, he is now exactly over that point, and for which, see here, 1.03 meter is the depth of the pipeline from this particular point. So yes, very easy, very simple. Uh, but yes, identifying metallic object. So new technologies. Next technology is GPR, ground penetration radar, as you might have heard. It is nothing but a scan. It gives you a scan, but data interpretation is some experts in the field of geophysics are required for the data interpretation. But yes, up to 6 meter you can work by using this technology, GPR, ground penetration radar. It's like a scan. You have to move a vehicle along certain paths for which you need to have a data sets, and then you get a scan like this, and the geophysicist can very easily interpret this database, and you can get the scan or the pipe diameter, pipe location. Even the non-metallic objects are identified here. So, yeah, in general, it gives you dielectric constant or that change of resistivity, and by the change of resistivity, the strata can be identified or the material can be differentiated. Okay. Then comes a technology called as LIDAR technology, a very common, very popular these days, a very buzzing word, LIDAR technology. It is nothing but a scanner, you can say. I'll share, few of my projects which were conducted by using this, so that you will be able to understand the capacities of this. You can, you can handheld this lidar. I'll be sharing one of the project जहाँ हमने ना हाथ में लीडर पकड़ के काम किया था. Then we can mount on the tripod. Then there are few lidars which you can connect to the drone. There are lidars which you can mount on the vehicle. Okay. So we'll be discussing about those. But it is very super accurate system, and it gives you loads of data. Even if in a say fraction of second, I'll get millions of points of this room where I'm sitting, and yes, the data. Then we need to interpret this data or utilize it data for the desired purpose. So this is the top left vehicle tripod mounted lidar, and you can even put it inside the industry, and every pipeline will be mapped. Whatever objects are visible to this instrument within a say 300 meters corridor, that data can be identified or mapped, or point clouds can be generated. Very super accurate system, very fast. And this I'll share this one project. Many of you may be knowing a Diksha Bhumi at Nagpur. My job was to identify the profile, the inside profile of Diksha Bhumi. So I used only this tripod mounted uh, scanner, LIDAR. It has scanned everything for me, and millions point data was collected. See, even 1 meter by 1 meter, I could get thousands of points. So it was very much helpful for me to precisely map or find out the um, geometry, inside geometry of this particular Diksha Bhumi. Then, as I told you, this lidar we can hold in our hand and we can move like this calibrating, gathering certain ephemeris and information, and now this person will lift it up and move. Here, my job was to identify deformation in tunnel. Okay, so railway tunnel. Many of you might have traveled along Itarsi on the railway line. Yeah, this sort of tunnels are there, and yes, they started moving, and inside the tunnel, the data has been created, and this is that data set. Okay, these are not a this is not an image. These are point cloud. ये देखिए इतने सारे पॉइंट्स है मेरे पास, इतने सारे पॉइंट्स हैं. सो ये देखिए हर पॉइंट का एलिवेशन डिफरेंट है, इसलिए कलर डिफरेंट दे दिया है उसका. सो ये इतना सारा डेटा हमारा कलेक्ट हो गया. फिर रिक्वायर्ड क्रॉस सेक्शंस कुड बी जनरेटेड लाइक दिस, और क्रॉस सेक्शन जनरेट करके हमने डिफॉर्मेशंस हमने आइडेंटिफाई करके क्लाइंट को दे दिया. Then another way of using this lidar is we can mount it on a vehicle. ये vehicle mounted lidar है, जो कि बहुत एडवांस्ड और बहुत फास्ट काम करने वाली ये टेक्नोलॉजी है. व्हीकल की स्पीड से, ये देखिए इस स्पीड से व्हीकल जा रहा है, और इस स्पीड से सारा आजू बाजू का डेटा स्कैन हो रहा है. The data is being scanned with this speed. So imagine कीजिए कि मेरा सर्वे कितना फास्ट हुआ. मुझे फॉर एग्जांपल नागपुर से अमरावती तक का अगर सर्वे किसी ने करने बोला, जीपीएस बोलो, टोटल स्टेशन बोलो, इससे क्रॉस सेक्शन करते 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 मुझे 1 साल लग जाएगा काम करते करते मैन्युअली. और वहाँ यहाँ 2 घंटे में हम पहुँच जाते हैं वहाँ पे, कहाँ अमरावती में, और डेटा मेरे पास आ जाता है. डेटा कैसे आता है? इस प्रकार से डेटा आता है. आई गेट अ पॉइंट क्लाउड. ये देखिए व्हीकल मूव हो रहा है, डेटा कलेक्ट हो रहा है पॉइंट क्लाउड के फॉर्म में. यहाँ इमेज में हर चीज पॉइंट है. पॉइंट क्लाउड बोलते हैं हम उसको, जो हम पहले डिस्कस किए थे. सो लॉट ऑफ इंफॉर्मेशन इज बीइंग गैदर्ड एंड व्हिच कैन बी एनालाइज्ड. आपको पोल की इंफॉर्मेशन मिलती है, आपको घरों के आजू बाजू के पेड़ों की हाइट, पेड़ों की विड्थ, है ना, ये सारी इंफॉर्मेशन यहाँ पे मिल रही है. कैप्चर हो गया डेटा, और एक बार डेटा कैप्चर हो गया तो उस डेटा को हम प्रोसेस और एनालाइज बिल्कुल कर सकते हैं. व्हाट वी कॉल असेट मैपिंग. ये बिल्डिंग है, फोटो है ये बिल्डिंग का, और ये हमारा पॉइंट क्लाउड डेटा है उसी बिल्डिंग का, पॉइंट क्लाउड डेटा. तो ये पॉइंट क्लाउड डेटा से देखिए यहाँ होल्डिंग है. तो ये होल्डिंग हमने एरिया निकाल लिया. यस, होल्डिंग ऑफ 6.4138 स्क्वायर मीटर का यहाँ पे होल्डिंग है. या बिल्डिंग की हाइट हमें गिनना है, तो बिल्डिंग की हाइट गिन ली है, विड्थ गिनना है, एंक्रोचमेंट गिनना है हमें. देखिए कोई भी पॉइंट के कोऑर्डिनेट चाहिए, यहाँ पे ये देखिए एक्स वाई जेड कोऑर्डिनेट आगे लिखते हैं। फिर हाइट कितना है, ये पर्टिकुलर एंट्रेंस का जो गेट है इसकी हाइट हमें कितना है, 4.113 मीटर्स की इसकी हाइट है। सो ये देखिए सारा डेटा हमारा कैप्चर हो गया है, हर पॉइंट को कोऑर्डिनेट्स है, और इसको हम ऑटो कैड में या हमारे जीआईएस के सॉफ्टवेयर में ये सारा डेटा हम लोग ले सकते हैं और इस सारे डेटा का एनालिसिस कर सकते हैं। ये कोई शायद मल्टीप्लेक्स है नहीं, ये कार का शोरूम है शायद। हाँ, ये कार का, हुंडई कार का शायद शोरूम है। सो इसका हमने विड्थ गिन लिया, 31 मीटर समथिंग। इसका हाइट गिन रहे हैं अभी, या 15 मीटर की हाइट आ गई उसकी। ये हम लोग कुछ भी जो भी हमें डिस्टेंस चाहिए वो गिन सकते हैं। कार खड़ी है, कार के डायमेंशंस, कंपाउंड वॉल के डायमेंशंस, कंपाउंड वॉल की हाइट, रोड सेंटर से बिल्डिंग कितनी दूर है। देखिए हर पत्ता भी यहाँ पे आ रहा है, पेड़ के पत्ते के भी कोऑर्डिनेट्स आ रहे हैं। रोड सेंटर से हमारी ये बिल्डिंग कितनी दूर है उसके डिस्टेंसेस यहाँ पे लिखे जा रहे हैं। सो ये सारे पॉइंट क्लाउड को एनालाइज करने का यहाँ पे चल रहा है। पोल, इलेक्ट्रिक पोल है बीच में, वहाँ लैंप लगे हुए हैं, उसकी हाइट यहाँ पे हम लोग गिन लेंगे। ये पोल की हाइट हम लोग गिन रहे हैं, 9 पॉइंट समथिंग मीटर की ये पोल की मेरी हाइट है। अब डिस्टेंस बिटवीन पोल्स, ये एक पोल है पॉइंट क्लाउड उसका, फिर ये दूसरा पोल है, और 24 मीटर का डिस्टेंस है ये दो पोल के बीच में। So very fast, very accurate, super accurate system. Millions of point data is available. You can extract whatever information you are looking for based on your application. So yes, very base system for conducting a linear survey, especially along the motorable roads. Now, this same instrument can even be used for identifying the road surface characteristics, road condition assessment, what we call. Everyone need a smooth road, and yes, what is there? What are the parameters which define the road as smooth? Those are raveling, potholes, age, cracks, bleeding, rutting, disintegration. These are the properties which obstruct or which should be quantified and which should be rectified. So this my particular instrument called as mobile lidar or network survey vehicle helps me even to get these parameters. I can even get the depth of the crack or the width of the road crack or the dimensions of a pothole, and this data is being captured and stored, and the data can be downloaded and automatically the reports are generated as far as road conditions are concerned. So this helps us to identify the faults or the defects in the road and to take a corrective measures. And after taking a corrective measures, once again we can go and run this and check the extent of repair, or to what extent my what is the riding quality of my road. Like one of the project recently we have done in Nagaland. These are gist of the information what which we could extract from the NSV. Like for this 34 kilometer stretch, the raveling affected area was 4.25%. There were 263 potholes. Edge breaks 4.68 square meter. Cracking was 15.8% of the area. This I am talking about the summary of entire road, but yes, for every 1 meter we can get this sort of information, and you can utilize it for the betterment of mankind and improving the riding quality of the road. So based on these parameters, based on the observed readings, as per the standard, the road rating is given to a road, poor, bad, fair conditions. And what we could get is there were too many potholes, that is very poor condition as far as pothole is concerned, and poor condition as far as road roughness is concerned. So yes, this sort of analysis is possible, and we can maintain the road quality. So this is how the lidar works, and this is how we get the information and we can interpret it. And really this has changed the expectations of common people. It has changed the measurement pattern for we the engineers, and we can analyze the things very precisely and rectify the things as per the defects identified, precise defects identified. So quick data is being gathered and represented. Drafting becomes very easy. Very less resources are required. You can imagine it will take me 1 year to collect this data from Nagpur to Amravati, but yes, in a couple of hours I could collect that data. That is what resource optimization I'm talking about. And the data interpretation very easy, and we get point cloud data. So yes, this is where the technology stands as on date, and the technologies are growing exponentially. Very soon, we'll come with some different technologies, maybe based on some different principle of operations, and we as a engineer should make ourselves aware about these technologies, and this sort of platform certainly helps us help me to make this technology popular by sharing my information knowledge with you, and for you to gather the knowledge and to use it for your further studies or further career. So, ladies and gentlemen, it is our responsibility to make these technologies more popular, because benefits are many. At the end of the day, the common man will be benefited if we move towards the technology. So my project monitoring becomes easy. I can optimize various activities. We can provide the better surface or better quality or better construction for our society. So this is our collective responsibility to make the things more popular. So I think it is around 1 o'clock. As far as my presentation is concerned, I'm done here, and I'll try now to answer your queries.
I requested all the participate if they have any query, they can ask the sir. Okay, sir. If anyone asks any question, we'll let you know by through your email and all the things.
Yeah,
Thank you,
sure.
sir.
Definitely. Yeah.
Thank you, sir, for your informative session. It's a pleasure to have with us, sir, for your valuable time and all your support, sir. Thank you, sir, so much. Thank you.
Okay. Thank you,
Thank
bye.
you.